My name is John Dan. I'm the Acting Associate Dean for Research in the Faculty of Agriculture here. So it's my pleasure to actually present the speaker to you this afternoon, and also welcome to the second seminar this year. Speaker today is Dr. Fabio Mattos. He's a professor in Agribusiness and Agricultural Economics. I guess I would ask the head of the department, Dr. Olson, to introduce the speaker.
Thank you. We sure are happy with this wonderful turnout we have here today. So nice testimony in terms of the interest of the subject and the speaker. Fabio came on stream in our department about a year ago, exactly a year ago. Very pleased to have him join us. He comes with a really nice, in-depth background, particularly in areas like risk management. His major professor at Illinois was Dr. Garcia, who's one of the better and more renowned individuals in that field in the United States and Canada. And what you'll be treated to today is sort of one of the themes that Fabio was exploring in terms of his thesis work, and it's sort of somewhat tangential to one of the major themes, and I think you'll find it of tremendous interest. One little side comment, because I know that people have a very wide range in terms of their interests. One of the things that we sort of got in the bargain for free with Fabio is a Brazilian background. And so we have an individual on staff with both work and study experience in Brazil for anyone who ends up looking and exploring work in Brazil down the line. And of course, Brazil is one of the massive agriculture powerhouses these days. So I thought I'd just give you that background. So thank you, Fabio, for agreeing to do. What's that?
That's warm too.
Okay, thank you. So what I prepared to talk about today is essentially the one line of research I have been spending quite a lot of time in the last couple of years, and it has to do with how people make decisions in conditions of risk. Okay. And what we're going through today in the next 45 minutes, I'm going to start by giving an overview of decision models in economics, starting with the standard theory, and then talk a little bit more about a new, relatively new area of research, which is called behavior economics. I'll go over a few examples of some key aspects of behavior economics, and then we're going to see some studies that try to apply those behavioral ideas into agriculture. And towards the end, I'm going to talk about new work, new project that I'm starting to work on right now. So let's get started about decision. Traditionally, when we talk about decision-making economics, we rely on the assumption of rationality, basically meaning that we tend to make rational and consistent decisions, okay? Meaning that we know what we want, okay? We know how to get what we want, and we know that what we want is good for us, or is best for us, actually. And we prefer more to less, so the more we can get, the better it is, the happier we are, and our choices are consistent over time. And even though this has been the dominant framework over the years, there has always been some criticism to this framework, and essentially because people realize that sometimes we behave in a way that cannot be explained by this standard theory. And there's a number of empirical observations showing that excuse me, we are not so rational and not so consistent in our choices. Okay? And those critics got more robust evidence or robust dialogue as they started to incorporate some insights from psychology. And those psychology insights basically suggest that economics should consider other motivations that the standard theory doesn't, like fairness, greed, fear, status, just to cite a few examples. And also they should allow, economics should allow for the possibility of that we can make mistakes sometimes. And using those insights from psychology, some economists developed a new line of research that became known as behavior economics. Okay? And the focus of behavior economics is mainly on the decision-making process, and not necessarily on the final outcomes of our decisions. Okay? And that's a point that sometimes people get confused with. Okay? So they are essentially worried about what happens in the decision-making process and how it affects the final decision. Okay? And just as a side note, a few years ago, in 2002, one psychologist, Daniel Kahneman, was awarded the Nobel Prize in Economics for his work related to this field of research. But let's move on. We'll go back to behavior economics. One main assumption of behavior economics is that we show bounded rationality, as opposed to the full rationality, so to speak, that standard theory assumes. And by bounded rationality, they mean that we just don't have enough time or skills to weigh all benefits and costs when we make decisions. So we are not, most of the times, we are not able to make fully rational decisions or fully rational choices. Okay. But still, this assumption of bounded rationality also assumes that we can make predictable errors in our decisions. Okay. And that's a point we're going to explore further later on. So in practice, what bounded rationality is saying is simply that we use a lot of biases and heuristics when we make choices, meaning that a lot of times we use rules of thumb or educated guesses, or maybe just common sense when we have to make choices relying on complex variables or maybe incomplete information. Okay. So that said, just want to go over a few dimensions of types of behavior that behavior economists assume and exactly what they mean, so that we can get a better picture of what we're talking about. One. All right. Okay. Try to keep it here now. Okay, so the first dimension, probably one of the most famous also, is what's called loss aversion and framing. And the idea here is that we hate losing, basically. We dislike losing so much that we change our behavior when we are faced with losses. Okay. And for example, if we are exposed to a loss of $1,000 or a gain of $1,000, okay, we hate losing that $1,000 much more than we enjoy gaining of $1,000. And the consequence of this type of behavior is that, depending on how choices are framed, we can behave in a different way. Okay. So let's see an example. Suppose that we are exposed to an outbreak of a new disease, and this disease is expected to kill 600 people. Then you are asked to choose between two possible programs to deal with this outbreak. In the first one, in program A, you know that 200 people will be saved. Whereas in the second one, in program B, you know that there's a 1 in 3 chance that 600 people will be saved, but a 2 in 3 chance that no one will be saved. And this exact experiment was conducted with a lot of different people in different places, different years, and they were all asked exactly the same questions, just changing maybe Canada and the 600 number, of course. And then after they answer this question, after they pick one of the two programs, the same group of people is asked another question. It's still related to the same problem, except that now the options are different. Now they have to choose between program C and D, and then program C, they know that 400 people will die, while in program D, there's a 1 in 3 chance that nobody will die, and a 2 in 3 chance that 600 people will die. And usually what people answer is this. In the first part, most people choose program A, whereas in the second part, most people choose program D, which makes absolutely no sense, since programs A and C are exactly the same. And programs B and D are exactly the same as well. Program A, when we say that 200 people will be saved out of 600, it means that 400 people will die, which is what program C is saying. And same thing for B and D. Okay. And this kind of result is consistent through all sorts of experiments of this kind that that researchers have been making. Okay. So essentially, what they're trying to show here is that if you think in terms of how many lives will be saved, it's much easier to make a choice than if you think of how many lives will be lost, for sure. So we are reluctant to choose a program that tells us that 400 people will die. But it's much easier to choose a program in which we know that 200 people will be saved, even though the only thing that's changing here is the framing. The choices are exactly the same. Let's see another example in the same line, now dealing with money. Say that you have investments that are increasing in value, and then you're talking to your investment advisor one day, and your advisor gives you two possible investment options, two other investment options. In one of them, you can have a sure gain of $240, and in the other strategy, you have a 25% chance of making more money, $1,000, but also 75% chance of making nothing. And when asked about this, most people choose the sure gain of $240. Then think about another situation now involving losses. You have investments, but now they are losing value. And then you go talk to your investment advisor, and he offers you two alternatives. The first strategy, you realize a loss of $750 and stop there, and you're out. In the second one, you have a chance of breaking even, a 25% chance of losing nothing. But at the same time, you have a 75% chance of losing even more than that, losing $1,000. And in this situation, most people choose the second option. If you compare both, what you see is when we talk about gains, people are much more willing to guarantee a sure gain, so to avoid taking more risk, even if taking more risk means that they might be able to make more money. And on the other hand, if you talk about losses, people are more willing to take risks in order to avoid losses, even though taking more risk in this case means that they can end up losing even more. Okay. That's similar to the previous example about the outbreak, and similar to a number of other examples. There's lots and lots of experiments like this, and all of them show exactly the same thing. That we are more willing to take risks when we are losing or in a situation that involves losses than when we are gaining or in a situation that involves some kind of gain. Okay, so that's one dimension, one idea of behavior that came up with behavior economics. Another one has a fancy name of status quo bias, but it simply means that we don't like changes. It simply means that we are reluctant to change whatever is going on right now with us. So if you have a number of options and we have to pick one of them, we show a tendency to stick to the one that perpetuates the status quo, the current situation. Okay. And there's a nice example in this study by Choi et al. And they look into retirement savings plans in 3 large US companies. And what happened in those 3 companies is that at some point they introduced a new program for their retirement plans, an automatic enrollment program. So any employee hired after this program would be automatically enrolled in their retirement fund. And they would automatically contribute 2% of their pay every month. And if they wanted to opt out of this program or change the monthly contribution, they had to call a toll-free number and let the company know what they actually wanted to do. And then they compared what those employees under the automatic enrollment plan would have done compared to what the other employees had done before them, the ones that were not in the automatic enrollment program. And what they found is two things that are important. First, participation in this retirement plan was much larger when employees are under the automatic enrollment plan than compared to the ones that are not under this plan. And second, the participation increases quickly, much quicker, in the automatic enrollment plan as opposed to the non-automatic plan. And what they suggest in this case is that even though some employees maybe didn't really want to participate in that plan, or if maybe if they wanted another type of other value for the contribution, they would be maybe too lazy, or maybe never had enough time to call the toll-free number and make whatever change they wanted. So they would have this impulse to keep things as they were. Okay. And the same thing happens if you look at the contribution, the monthly contribution. See that for the orange bars, which are the employees hired under the automatic enrollment plan, the majority stays with the default contribution, the 2%, which is not what happens if you look at the employees that were in another regime. There's much more diversity in terms of monthly contributions for the employees that don't have a default option. Now let's talk about another point of this behavioral economics, and which is called probability weighting. And this idea is simply that we don't treat probabilities as they are stated. So for example, if we see a 10% probability, our actual choices don't reflect that probability. We might behave as if the probability was higher than 10% or maybe lower than 10%. Okay. And this has to do, this kind of behavior can be related to a number of things, like overconfidence. So we think we are so good that we can somehow make probabilities increase out of nothing, or optimism or pessimism, okay, or a number of other things that don't want to discuss in much detail this, because that's not the main point of this issue. Let me show you an example, just to give you a better idea of what we're talking about. I did a study with a couple of other professors a few years ago, and we looked at a group of 15 professional traders in futures and options markets. And we asked them to ask a series of questions involving risk. So basically, they had two options. Both options had gains and losses with given probabilities, and they had to make a decision which one they would go for. And based on the options that they made, based on the choices that they made, we were able to evaluate the actual probabilities that they were taking into account when making that choices. And what we found is all of them exhibited some degree of probability weighting, meaning that all of them were not making decisions based on the probabilities given to them. So for example, see in this table, on the left column, we have probabilities, some probabilities that were given to them, that were stated in the problems that they were analyzing. And then let's take a look at the trader number 6 on the right. Those are the probabilities that this trader actually took into account when he was making choices. And as you can see, they don't match at all, except for the 50%, only slightly. But what happens, what this trader was doing is, for small probabilities, 10, 20, 30%, he tended to overweight them. He was behaving as if those probabilities were larger than they really were. And the opposite behavior for larger probabilities, 70, 80, 90%. In this case, he tended to underweight those probabilities, to treat them as if they were smaller than they really are. And that's a very common pattern of behavior when you do studies like this. There's a clear tendency to overweight small probabilities and underweight larger probabilities. So there's a clear tendency to think that small probabilities are actually larger than they really are, or that large probabilities are actually smaller than they really are. Okay. And just to give you another example, different from the first one, see if trader number 4, this trader is either he's very overconfident or he's very optimistic, but he overweights all probabilities. He always thinks that the probabilities are much larger than they really are. That's not a common type of behavior. Okay. I just put this one here because to show you that there are several patterns of behavior when people deal with probabilities. The most common, as I said, is this one that trader number 6 was showing. But you can find all sorts of behaviors regarding probabilities as well. Okay. Now, one last point before we go to some applied examples. Another frequent discussion in behavior economics has to do with sequential choices, or how we behave when we make the same kind of decision time after time. And essentially, the main concern here is whether prior outcomes, or whether we made money last week or whether we lost money last week, has an effect on how we behave this week. So essentially, they're trying to see if people tend to take more or less risk depending on whether they had a prior gain or prior loss. Okay. And in general, studies that look into this question find mixed evidence. So some people tend to take more risk after they make money. Some people tend to take less risk after they make money. There's no clear pattern of behavior in this case. Okay. And, almost forgot one point. And there are a few studies that try to look at how people frame prior gains and losses in their minds. And they find that this framing can have an impact on current decisions as well. For example, if I made money, if I invested my money last year and I made a lot of money out of that investment, and I think that the reason why I made a lot of money is because I'm really good with investments, and I'm really smart, and I can spot very good investment options, then I might be tempted to take more risk now because I believe that I made money because of my skills. Whereas if I think that I made money last year simply because I was lucky, I might not be so tempted to take more risk this year, because I might wonder whether I have the same luck again this year or not. Okay. And as one study I did with Phil Garcia last year, and we looked into this issue using almost the same group of 12 professional traders that I mentioned before. Okay. And we tried to look into, on a weekly horizon, try to look at how weekly gains and losses affect how much risk they take in the subsequent week. Okay. And we found evidence that prior gains and losses do matter when they make decisions afterwards for 9 traders out of the 12 in our sample. And again, the evidence was mixed. There was more or less risk-taking after gains or losses. So we couldn't really isolate one single type of behavior here. But more interesting than this, what we found here is also that the response to prior gains and losses can change depending on how much risk they are facing in the market. And specifically, we found that when there's a lot of risk in the market, they tend to be more affected by prior gains and losses. And when there's very little risk in the market, most of them actually don't really care what happened before. So they don't allow prior gains and losses to affect their risk-taking decisions in coming weeks. All right. Okay, so I gave you a quick overview of some types of behavior that are discussed in behavior economics. And there are a lot more studies looking into this kind of behavior. but almost all of them are related to activities and industries other than agriculture. You can find very few studies that try to use those insights into agriculture decision making. In the few studies that actually look into this, researchers tend to find that there is evidence that farmers, the producers, are also subject to biases and heuristics, just like everybody else. Okay. And in general, they find that producers tend to be averse to losses, they exhibit probability weighting, and they tend to underestimate price risk. And there's also one single study that tried to look at how prior gains and losses affect farmers' decision making in the subsequent year. And in this case, in this study, they found that farmers with prior losses, farmers who lose money on a given year, tend to take more risk in the next year than farmers who gain money in the previous year. Okay. So just to give you a quick overview of those studies, in this first set of studies, they're just looking for evidence of loss aversion and probability weighting. So one of them looked at seed producers in Oregon, another one some farming communities in Uganda, Ethiopia, and India, and the last one looked at wheat and cattle producers in Portugal. So, two of them just looked at one dimension at a time, either loss aversion or probability weighting. Just the last one looked at both dimensions, but all of them found some evidence either of loss aversion or probability weighting, or both in the last case. And a second set of studies. In these three studies, what the researchers did was to ask farmers to forecast prices and volatilities. And they did that for a group of grain producers in Illinois, or a group of corn and soybean and cotton producers in Mississippi, and also corn producers in Brazil. And what they found, specifically in terms of volatility at the bottom, in all of them, they found that farmers tend to underestimate volatility, which was the point I made before, that farmers tend to underestimate price risk. In terms of prices, in terms of forecasting prices, just have two studies that look into this, and the results are not totally consistent. One of them found that farmers can actually do a pretty good job in forecasting prices, whereas the other one found that farmers tend to overestimate prices. They tend to think that price will be higher than they actually turn out to be. Yeah. Okay, so even though we don't have a lot of studies looking into this, actually not even though, actually, because we don't have a lot of studies looking into this, some researchers try to work on simulation models to see how farmers would make decisions and what the outcomes of those decisions would be if there was loss aversion and probability weighting. One study a few years ago looked at grain producers in Argentina, and they simulated land allocation decisions, assuming that producers are loss averse, and also that producers make decisions in terms of gains or losses with respect to some reference income that could be easily achieved. For example, they could just rent their land to somebody else. Then what they find here is that land allocation decisions tend to change dramatically when those two assumptions hold. So first, they look at how farmers would allocate land, assuming that they are not loss averse, or essentially that they are rational in the traditional definition of the term. And then they introduce those two assumptions and see what happens to land allocation decisions. And they find something like this, like in this example. They looked into a group of farmers that could plant soybeans, or either soybeans or combine wheat and soybeans on the land. In the first case, when they assume no loss aversion, they find that the optimal decision would be to combine wheat and soybeans. Then they introduce some loss aversion, a moderate level of loss aversion. And they find that, in this case, farmers would choose to split the allocation. 50% just for soybeans, another 50% combining wheat and soybeans. And then they try to look what producers with a high level of loss aversion would do. And they find they find that they would, most of them, they would put most of the land just to soybeans and leave just 20% for wheat and soybeans together. Okay. There are lots and lots of simulations that they did in this study. Okay. I'm just showing this simple one as an example of the kind of results that they got. But there are a lot of other possible combinations of land allocation. Some of them also include corn. Some of them consider different types of farm size. But in all cases, they find very different types of allocations when they have loss-averse farmers or let's call it rational farmers. Okay. Another study that looked into this question was, into this question of loss aversion probability weighting, was a paper that I worked on for a couple of other professors 2 years ago, and we simulated hedging decisions for soybean producers in Illinois. And the question here was, let's assume that producers exhibit probability weighting and also that they are loss averse. How would these two facts change their hedging decisions? Okay. And what we found is that when we consider probability weighting, producers tend to hedge much less than they would otherwise. But in terms of loss aversion, we didn't find a lot of difference in terms of hedging decisions. So for example, let's see here the proportion of the crop that farmers would hedge, assuming different degrees of loss aversion probability weighting. Let's start at the bottom, the orange circle. If there's no loss aversion, there's no probability weighting, if farmers are rational, the traditional sense of the word, they would hedge 87% of their crop. Now let's introduce loss aversion in this model, still assuming that there's no probability weighting. As we allow for a moderate level of loss aversion or a high level of loss aversion, the hedging decision doesn't change. They would still choose to hedge 87% of their crop. But these numbers change quite a lot when we allow for probability weighting, when we consider that farmers don't treat probabilities the way that they are. In this case, at the top row, when we think that there's no loss aversion, we're just saying that farmers exhibit some degree of probability weighting. See that the proportion of their crop that would be hedged decreases quickly as we allow for some degree of probability weighting. And see that it doesn't take a lot of probability weighting to change those proportions. Okay. Then, if you combine loss aversion and probability weighting, it doesn't. See, still for probability weighting, as you go from left to right, there are drastic changes in the proportion of the crop that will be hedged. Whereas, if you fix the same level of the probability weighting and just change the degree of loss aversion, proportions don't really change much. And at some point, for some levels of probability weighting, the loss aversion doesn't really matter, since they wouldn't be hedging anything. Okay. So those are a couple of simulations that try to explore how decisions or how the outcomes of decisions would change if we consider that producers are not rational, as the standard theory assumes. But still, and I mean that's fun to look at those things. At least I think so. And but an important question still remains here, which is, maybe it doesn't really matter whether I am loss averse, whether I exhibit probability weighting, or if I tend to stick to the status quo, or any other type of behavior you can think of in behavior economics. Okay. Maybe it's just a matter of each one of us being different, and we just behave in different ways. But at the end of the day, it doesn't really matter. You are able to get roughly the same results. So an important question that very few studies have tried to address is whether producers will be losing money or maybe making less money if they don't behave according to that rationality assumption. So maybe probably the most important question here is whether there's money left on the table if people are loss averse, exhibit probability weighting, okay, or are reluctant to change things, and so on, and so on, and so on. There's only actually one study that tried to look into this in an agricultural context. And this study was conducted a couple of years ago by Liu and was about cotton producers in China. Okay. The first thing that she did was to ask producers to answer a survey, and based on the results of the survey, she tried to assess whether they were loss averse or exhibited probability weighting. What she found was that 90% of those Chinese producers are loss averse, meaning that they tend to show a risk-seeking behavior after they lose money or when they are losing money. And also, she found that 90% of those producers tend to weight probabilities. And more specifically, in this case, they tend to overweigh small probabilities and underweigh large probabilities, which was that typical case that we saw a few slides ago in the table. But now, the main objective here, what she was really trying to look into, was how those types of behavior may change the rate of technology adoption among those producers. And more specifically, she was looking into the introduction of BT cotton in China. So she was intrigued by this graph, actually. This new technology, the BT cotton seeds, were officially introduced in China in 1997. But still, over the next 7 years, the adoption rate was very small in all the 4 provinces that she was looking at, which are the 4 main cotton-producing provinces in China. And she didn't really understand what was going on because, according to her calculations or her information, this new technology could bring more profits to farmers and expose them to the same amount of risk as the old technology. So she would think that farmers should be much faster to adopt this new technology, which was not what was happening in practice. And after a lot of statistical procedures, she came to the conclusion, or she found evidence, that those producers that show some degree of loss aversion, and even more that show higher degrees of loss aversion, tend to adopt new technologies later, while producers who exhibit some degree of probability weighting, they tend to adopt those new technologies earlier. Okay. She acknowledges that there are other factors playing a role here, that loss aversion and probability weighting are not the only explanations for this late adoption in technology that we saw in the graph. But still, she claimed that those 2 dimensions, loss aversion and probability weighting, can play an important role in explaining why this happens. And, oops. Okay. And so one last topic. I want to discuss some ideas related to current project that I'm starting on now, and that's actually with Stephanie sitting over there. She's a master's student in our department, okay. And this project will be used in full or in part as her master's thesis. And so, well, we started thinking about this project based on all those ideas that we have been discussing the last 30 minutes or so. And the main point is that we thought that if apparently a lot of people, or everybody, shows some kind of biases or heuristics in their decision-making process, producers could as well be affected by the same types of behavior. Okay. So what we're trying to do in this project is to get a better understanding of how producers make marketing decisions specifically, okay, and then examine what types of behavior that could be affecting their decision-making process, try to assess the costs of possible deviations from rationality in that the traditional sense of the word. Okay? And also try to discuss some possible ways to improve the decision-making process when we talk about marketing decisions. And we are pleased that there's a very unique opportunity to look into these questions in Canada, or in Western Canada specifically. And that's because all producers here have to market their wheat through the wheat board. So we know exactly where their wheat is going. And there are a specific number of marketing programs that producers can choose. And we know exactly what those programs are. We know we can discuss the expected returns from each program, the risks involved, the costs involved, or different characteristics of those programs that might play a role in how farmers choose them. And also, there is a default program. One of them, these market programs available to farmers, is a default, meaning that if they don't choose anything, the wheat board assumes that this is the program they are going to use, which in this kind of research is interesting because of one of those types of behavior we discussed earlier, the status quo bias, that people tend to stick to a default option. Okay. And finally, all those price alternatives are clearly defined, which is what I was saying in terms of expected returns, risks, costs involved, and so on and so on. So more specifically, we are interested in looking at some types of behavior. One of them, I just mentioned, the status quo bias. Here we're just trying to see if farmers tend to stick to the default program without paying attention to other alternatives. Okay. The second one is whether they make decisions in the current year based on outcomes from previous years. So if they lost money last year with a certain program, are they going to choose this program? Are they going to choose to another program this year simply because they lost money with a specific program? Okay. Or are they going to take into account expected profits or specific characteristics of this program? Okay. Or just simply realize that losing money on a given year can just happen to anybody. It's not because of a specific program, not necessarily because of a specific program. A third point is whether they place more weight on short-term outcomes and less weight on long-term outcomes, okay, which is a type of behavior that a lot of researchers find in empirical studies. So we tend to be more concerned of outcomes that happen that are closer to us in terms of time, and don't pay too much attention on outcomes that are just going to be realized 1 year, in 6 months, or 1 year from today. Now, the fourth one that's somehow related, whether they place excess weight on readily available information. If they open a newspaper today and see in the headlines that something bad is happening to wheat, something bad is going to happen to wheat prices, price will get much smaller, much lower, and within the next few months, they will be tempted to quickly lock in a price right now and avoid possibly facing more risk in the near future, even though other information available in the market might suggest that that's not necessarily the case. Then, number 5, the idea of loss aversion, trying to see whether they overreact when faced with the possibility of losing money, which will lead them to take an excessive amount of risk, or more risk than they would usually take. And finally, one last one, whether they choose programs that their friends or their neighbors are choosing, or whether they would choose this program simply because their friends or neighbors are choosing, okay, which is some kind of a herd behavior. They just follow what their friends are doing. Okay. And there's actually a nice quote. I forgot to put the researcher who said that. But there's this nice quote to illustrate this point that says that worldly wisdom teaches that it's better for reputation to fail conventionally than to succeed unconventionally. So they just follow what everybody else is doing. Even if that doesn't work, at least he was with everybody else. He made the same mistake that everybody else did. And he doesn't take the risk of choosing a different program losing money while everybody else was making money. So some questions that we hope to answer with this research is whether producers choose the same marketing strategy every year, year after year, no matter what's happening in the market. Or if those producers could be making more profit if they had chosen a different strategy rather than sticking to the same one year after year. Also, if the results in previous years would lead producers to take safer or riskier strategies in the coming years. And finally, what types of behavior among some of the ones that we discussed before could be affecting their decisions, their choices. Okay. And oops, as I said, that's a research project we're starting right now. So we don't have a lot more than this. And even because of that, if there are any suggestions or comments about any of this, either towards the end of the presentation or later on if you remember something, please feel free to send an email, give a call, or just stop by and give some ideas. Okay, so some conclusions to finish this talk. So even though there are not a lot of studies, there seems to be some evidence that farmers tend to exhibit biases and heuristics in their decisions, just like everybody else in the world. And but as Daniel Kahneman, that psychologist that I mentioned in the very beginning, said once, no, perhaps the most important point here is not whether people don't behave rationally in the standard sense of the word, but maybe it's much more important whether those, let's call it mistakes, are systematic, whether they can be predictable. Okay. It's not really a big deal if we make mistakes in our decisions, as long as those mistakes can be predicted. And even more, if once they can be predicted, they can be, to some extent, corrected. Okay. So a lot more work is needed in agriculture to explore whether those biases and heuristics actually lead to systematic behavior that would allow us to predict and maybe to some extent correct them. But even more important is whether those biases affect the final outcomes in terms of money. Do I lose money? Again, the same question that I mentioned before. Do I lose money if I make those kinds of mistakes? Or do I make less money? Or could I be making more money if I were rational in the standard sense of the word? And then for this kind of question, that we need a lot more work, not only in agriculture, but also in other industries, in other activities. There hasn't been a lot of studies trying to look into this question, which is actually, in my opinion, the most important question related to this field of study. And finally, one last point, just to make it clear, and there's a lot of misunderstandings related to this point. No, behavior economics is not about looking at people and saying, look, you're making right decisions or making wrong decisions, you're irrational, or Karen is rational. It's not about this. Much more important than this is what behavior economists are trying to do is to get a better understanding of the process, of the decision-making process, and trying to see what factors are important when people make decisions, and how and what the implications of those factors are to the final outcome. Okay? So that's what I had prepared. Again, any comments, suggestions, or questions that maybe we don't have time to go over today, or maybe if you remember something else later on, just feel free to send me an email or just stop by.
Well,
thank you.
Round of applause.
Thank you.
Some time actually for questions or discussions for Fabio. Floor is open. Yes.
Thank you for the nice talk. It was very interesting. You mentioned in one of the earlier slides when you were talking about 200 will be saved versus a third chance that 600 people will be saved.
Right.
The 200, I didn't quite understand. You were saying that those were the same?
Yes. Let's go back there.
That, like, 100% the 200 people will be saved. So how can it be the same as that other option?
There's 600 people.
Oh, okay. In both cases, there are 600 people. Okay. In both cases, we're talking about 600 people. Okay. So, yeah. So I'm saying is that in a sample of 600 people, if you say that 200 will be saved, that implies that 400 will die. Or if you say that out of 600, if 400 will die, that means that 200 will be saved. Okay?
It's comparing A and B, right? Not A and C.
Yeah.
Which one are you comparing?
What I understood is that he was comparing A to B, and he was
Yeah.
saying that both of them are the same. But I felt that, or I thought that both of them are not the same, because you know for sure that you have 200 will be saved. In the other case, you don't know that. It's a probability. So
Right. No, the point is, people have to choose between A and B, and then between C and D. What I'm saying is that if the majority choose A in the first part, they should choose C in the second part, because A and C are the same. Whereas the ones who choose B in the first part should choose D in the second part, because they are the same as well. But the point here is that the choices are not consistent.
B and D just try to confuse people?
No, but the expectance is the same in all four cases.
Yes.
Yes, true. Yes, Gary? Sorry.
Fabio, when you're going through your traders and you're saying that the one guy was consistently overestimating probability, how do you differentiate that guy from just being a risk lover? Like, were you giving him a bunch of risky bets and he kept taking the bets? Is that how you measured it? So how would you know if he was just a guy who likes risk?
Oh, well, one implication of overweighting probabilities is that people are more risk-seeking than if you are just objective, related to probabilities.
So many risk neutral to start with, and then see what how they behave.
Oh, no, I see what you mean. No. There was a first part of that study looked at risk attitudes. So we looked into whether they are naturally risk averse or risk lovers. And then the second part we looked at probabilities. Okay. So, for example, in that case, for that trader who consistently overweights probabilities, that suggests the risk-seeking behavior. So even if that person is naturally risk averse, the way that he deals with probabilities can make him behave in a risk-seeking manner. Okay.
If you were to take a population of 500 producers and look at the decision-making processes of them, and then as individuals, and then to look at the same group of 500 as, let's say, a co-op, a cooperative, and look at the decision-making process and the outcomes, would they be similar, or is the process totally different as soon as the individuals become a collective?
It should be different. There have been a few studies looking at group decisions rather than individual decisions, and all of them find that when making decisions as a group, the outcomes can be quite different from what they would have chosen if they were making decisions individually. Okay. So
More rational as a group.
they I don't remember that. I don't think there's a clear pattern of more rationality as a group, but I do remember that they tend to find that group decisions tend to be more risk averse than individual decisions. So people tend to control each other better in groups.
There might be one individual who may manipulate
Do you think that the risk-taking behaviors would be different for farmers where their whole income comes off the farm versus those that have off-farm jobs? Yes, in terms of security.
Yes, for sure. There are some studies looking into this, not for farmers, but looking for other activities in which, for example, in trading. There are a few studies related to trading in which they look at professional traders that make all their income from trading and what they call amateur traders, which people who trade on the side and they have I was going to say real job, but that they have and more, right. And so they find very different types of behavior between these two groups.
So are the ones that have some secure income higher risk takers then, in general, than those that have no alternative income, or is that not?
It's hard to tell. It's hard to tell. It happens in some cases. It happens, but what's clear in those studies is that the types of behavior, the types of decisions are very different between the two groups. But it's hard to isolate a specific risk-taking behavior that is a characteristic of each group.
Just related to your current research that you're working on, with the risk assessment that you're kind of trying to model, how are you going to put in the volatility that shows up in other parts of agriculture, like volatility and input pricing and things like that, and how it affects the whole gamut? Because that becomes the factor when you're dealing with something like wheat production.
Yes. We're still not sure, basically because we're still not sure if we can get data to look into this issue. Okay. So, sorry, but the answer is I don't know.
One question.
Right.
Oh, yeah.
Right.
I was just going to ask if there's any evidence that the degree of loss aversion is a negative or decreasing function of income. Because in like developing country adoption of new technologies and practices, it's often slowest among the lowest income rate because they're subsistence farmers. They really lose.
No, there's no evidence about that.
There's no evidence to the contrary either, which just hasn't been, So I imagine it would be a decreasing function.
Actually, there are not many studies looking into this issue. In general, those studies are much more concerned with probability weighting, for example, than with loss aversion. And one of the reasons is one of the examples I showed, that the probability weighting tends to have a much larger impact on decisions than loss aversion do.
So that scale that has data for years and years gone by. Can you use that data and correlate that with prices or inputs for the last 20 years? Is that what you're looking to do?
Could be. So, it depends on how the data is aggregated. Okay, it's not only whether the data itself is available, but exactly what kind of data is available. If, for example, if you have very aggregated data, for example, input prices for on average for the whole country, it might not be too useful. But that's one source to look into for sure.
Yeah, I found it interesting that the behavioral economics is a new field. Of course, with any science, when you find it, you think it's so obvious. But like, in your opinion, why did it take so long for us to understand actually people's behavior, psychology, all that environmental effects that affects our decisions, rather than that cold economical theory? Like, why did it take so long for us to understand that?
When I said new field, I said it's a relatively new field. It's new relative to the standard theory. A lot of studies trying to link psychology to economics, or some studies in psychology and economics, it started to show up in the late 60s, early 70s. And so the large body of studies came up in the early 80s, and then a lot more came after. So it's not completely new in the sense that those ideas have been around for 34 years already. Oh, for agriculture? One of the problems, certainly not the only one, but in my opinion, one of the major problems is to get data. And also because the time frame in agriculture tends to be much longer. And if you think about farmers' decisions, it's usually from 1 year to the next. So, if you want to have a reasonable number of observations, you might need to have information for 15, 20 years. While if you look at a lot of studies like this are done in financial markets, that you can have a lot of information every single day. So in 1 year, you can have 250 observations for thousands of people. So usually, it's much easier to get data outside agriculture than within agriculture.
Yeah, after the last question, may I make a little announcement on an upcoming event?
Oh, okay, so last question. I don't know, Bob, here. One of you guys go first.
I think it's an old diploma student of mine, and when I used to ask them to base their price risk on the history of prices, they always looked at me like I was crazy. Right? I thought it was crazy. Because it's really hard to come up with what real price volatility is. If you look at the last 10 years, how do we know that innovation or tastes and preferences aren't going to change and really throw it all for a whack? Like, how do you come up with price? When you say we're estimating, or irrational or estimates of volatility of prices, how do we know what real volatility is?
No, we don't. And that's part of the problem. This kind of question is exactly what one of the major motivations for people who started studying in this area. That either because of lack of information or because variables are too complex, there's just no way we can figure out what the real world looks like. And this example of volatility is a quite good example about this. And I agree with you, there's just no way we can know the real volatility.
But you're going to try it on CWD.
What's that?
You need that for that CWD stuff.
I need how producers see volatility, not necessarily the actual volatility. Because one important issue here is specific about risk is not necessarily what the actual risk is, but how we perceive risk. Okay, there can be a lot of risk outside, but if I think there's no risk, I just don't care. I'm fine. Whereas there are people who are extremely risk averse, who might think that there are much more risk in the world than there really is. And there are a lot of studies about risk perception as opposed to actual risk. And there can be a huge difference between how we actually perceive risk and how much risk there really is.
Question? Yeah? No? Okay, yes.
When you're talking about risk perception, I'm kind of wondering how willing we are to accept something when it is a sea change. The American Farm Bill, for instance, in 2002, was a major shift that it took everybody over a year to even come to grips with saying, yeah, it's really happening. And, we've got climate change, we've got the United States ESA, the, Emergency Energy Independence and Security Act. I mean, there's major changes beyond technology. I mean, it's so hard to grasp some of these. How do we factor some of those things into the framework for decision making when people can't accept it till after the freight trains hit?
You mean the process that people use to assess risk? You're asking how those things affect risk perception?
Are we so risk averse or have so many blinders on that we can't see it until after it's happened? Do we have to be up to our necks in floodwater before we can realize we need to get the boats out? whether it's marketing or anything else? Does that come out of any of your studies?
No. Most studies, I've never done any study on this. Most of the ones that I have seen about risk perception, they don't really try to see how different factors influence risk perception, but rather they just try to see if the way that we perceive risk, or if the amount of risk that we perceive is the actual amount of risk that is out there. Now, the problem they're asking is more related to how to assess the actual amount of risk related to all those factors. And in most studies, they use some sorts of simplified assumptions in terms of risk. I mean, they use controlled experiments, so they can actually determine a specific amount of risk, and then they see how people react to that amount of risk. What I understand, your question is much more complex than this kind of controlled experiment.
Well, I guess one of the things people, we tend not to react to disasters until it happens. Like the Farm Bill, for instance, was one sort of disaster.
Yes, but yeah, I could think of a few types of behavior to justify that. One, for example, that I mentioned, that we tend to react, we tend to change very slowly. We tend to stick to the current situation as much as we can. The way we deal with probabilities can be a factor too, which is related to risk perception. So the way we deal with probabilities maybe doesn't expose to us the actual risk involved in these problems that are mentioned. Or trying to follow how other people behave, and then it's kind of circular argument. If people around you tend to react slowly, you feel like there's not as much risk, or there's not as many reasons to be worried about that. And there are other types of behavior that have been studied that could explain this, but it's hard to point a specific one or trying to come up with a major explanation for this.
Have we learned how to kickstart the process, though, to motivate change?
Yeah, I believe so.
How do you see that?
Right. I see no hands up. I guess, Brian, you want to make an announcement before we close the session?
Yeah, actually, Carol, I thought that Fabio would direct you to a book on his bookshelf called The Black Swan, which is an excellent discussion of that question. The Faculty of Agriculture last year was very pleased to kick off a major lecture series that we'll be doing every year called the Darrell Craft Lecture. And it was pretty well full house last year, and we're hoping the same thing will be this year. The individual who will be giving the presentation is from the Policy Institute at the University of Tennessee, and it will basically be on demand and world population and can agriculture keep up in the very, very long term. Excellent speaker, excellent program, and I'd like to see you all there. It will be on Tuesday, February 23rd at 3 o'clock in the Richardson building, or the Richardson Lecture Theatre in this building. And so I hope to see you all there and pass the word out as well. We'll try to get the word around to everyone possible. So thank you.
Well, on behalf of the faculty, I'd like to thank you all for attending the seminar, and also, I guess, Brian will introduce the speaker, of course, Fabio, for your wonderful presentation. There's a small token, I guess, book of faculty history signed by Dr. Dean Kevin Whittem.